Thank you for joining today's NTT R&D Forum Technical Seminar. Thank you. I'm Ichiro Kudo from the NTT Research and Development Market Strategy Division. We're driving market-oriented R&D centered on tsuzumi 2. My role is connecting R&D with business. Thank you for being here today. In this session, our theme is tsuzumi 2 and the new landscape of AI business, challenges and prospects of a Japan-originated LLM. We'll have a 20-minute presentation followed by a panel discussion. Let me introduce our three speakers today. Please come in. First, our opening speakers, Kyosuke Nishida, Senior Distinguished Researcher, NTT Human Informatics Laboratories, and Taichi Asami, Senior Research Engineer at the same institute. Mr. Nishida specializes in language processing. He's both the creator and architect of tsuzumi 2. Mr. Asami specializes in audio processing. He's researched and developed various voice services and shipped numerous products. Mr. Arakawa is with NTT DOCOMO Business, leading their generative AI agent business. He's driving growth in this space. Now let's begin with Mr. Nishida's presentation.
Good morning, everyone. I'm presenting tsuzumi 2, NTT's evolved LLM. I'm Nishida from NTT Human Informatics Laboratories. Thanks for being here. On October 20th, we launched a major evolution over the previous tsuzumi 2. This model's key features are: it runs on a single GPU in your on-premises environment, and NTT developed it in-house. These are the defining characteristics. The result: exceptional Japanese comprehension and generation. It handles high-demand RAG tasks and operates as an AI agent. Exciting achievements. We're exhibiting tsuzumi 2 on the basement level today. Please stop by. Let me show you tsuzumi in action. Here we're feeding RAG format patent publications and related papers into the LLM to assess deterrent strength. How much does this patent constrain current priorities? And to expand into new technologies, which direction should be pursued? The LLM generates these recommendations. On screen are papers and patents in full text. The LLM reads this information, and we've asked it to write a report. We specified a detailed format. Whether it follows that format is the key test. That's what we need to verify. On the left, tsuzumi 2. On the right, OpenAI's GPT OSS 20B model output. Both GPT OSS and tsuzumi 2 follow the instructions while synthesizing the information. Even with massive input like this, it accurately extracts relevant information, drawing on its own knowledge base to produce this report. With this release, tsuzumi 2 is ready for real business applications. We believe we've reached that milestone. Today's presentation covers 4 parts. Through developing tsuzumi 2, we're building sovereign AI to support Japanese industry, AI development under our own sovereignty. First, building an LLM from scratch. What is an LLM and how do you build one? Let me explain briefly. An LLM predicts plausible continuations from input text. It's a massive language model. In this example, tell me about NTT. We call this the prompt. From this input, it generates a response as the continuation. That's the basic structure. Inside the LLM, text is divided into word-like units called tokens. The model consists of billions, in recent large models, trillions of parameters. These parameters define the model. More technically, given tokens 1 through t, it generates the next token at position t plus 1. That's the fundamental operation. Here, we pass in "Tell me about NTT," and it predicts the next token. Next token prediction is LLM's core characteristic. By feeding predictions back as input, it generates continuous output. That's the mechanism. Since generation is probabilistic, errors can occur. You may have heard the term hallucination. Due to this probabilistic variation, LLM outputs can contain errors. So why have LLMs evolved so dramatically? Next token prediction requires no human-prepared training data. That's the breakthrough. Simply collect massive amounts of text, shift positions like this, and you can learn next token prediction. This is called self-supervised learning. By learning next tokens at each position, we can train on massive text datasets. This is the key to LLM evolution. Here's how we build one. First, prepare massive text data and create a base model. This is called pre-training. Next, in post-training, we use instruction data for supervised learning. These instructions are user prompts to the LLM and their correct responses. We train on these paired examples. Finally, we perform alignment training. This uses preference data. For a given input, we prepare outputs A and B and train it to learn which is better. Through this post-training phase, we tune the LLM to respond in human-aligned ways. This is integral to LLM training. Now, how did we specifically train tsuzumi 2 using this process? Let me explain. First, some background on NTT's LLM journey. A bit of context. In 1980, our lab began researching natural language processing. Over 40 years have passed since then. A pivotal moment came around 2018. Google released a model called BERT. AI reading comprehension began to surpass human levels. Pre-training on massive text was shown to be effective. This was the turning point. We built our own reading comprehension model, taking first place in competitions and releasing Japan's then largest dialogue model. Around 2021, anticipating multimodal models, we developed a visual reading comprehension model. It reads text within images and generates answers. We were researching models still relevant today. Then, ChatGPT launched in late 2022. The world shifted dramatically, and we began developing tsuzumi. That was our starting point. In November 2023, we announced tsuzumi at this very forum. Commercial launch followed in March 2024. And now we've launched tsuzumi 2 commercially. That's where we stand today. As LLMs grow larger and more centralized, they consume enormous costs and power, creating serious societal challenges. We want to break free from dependence on massive LLMs, connecting diverse, efficient AI through networks, achieving social well-being through collective intelligence. We call this interconnected AI approach an AI constellation. Within this AI constellation, tsuzumi 2 will play a vital role. Regarding model size, since we built from scratch, we could determine the optimal size ourselves. Our guiding concept, a model that runs smoothly on a single GPU. We chose 28.6 billion parameters. This slide shows parameter counts for recent models. The horizontal axis, active parameters during inference. The vertical axis, total parameter count. These divide into two groups. One is dense models, which use all parameters during inference. The other is MOE, mixture of experts, which activates only specific expert modules during inference. We chose the dense architecture. Our goal, a stable model using all parameters during inference. That's the model we built. Our tokenizer also incorporates original technology. We represent the same text with fewer tokens, reducing training and generation costs. Take GPT-5 tokenizing this Japanese line of text as you see on screen. Each token becomes a very short character string. That's because GPT-5's tokenizer wasn't trained much on Japanese. Our tokenizer, however, as shown below, reflects Japanese grammar in its segmentation. This lets us divide the same text into fewer tokens, giving us a cost advantage in training and inference. This chart shows characters per token, averaged across Japanese, English, and 24 languages. For Japanese and English, tsuzumi 2 outperforms the latest open models, and even surpasses GPT in efficiency. Beyond Japanese and English, it operates efficiently and performs across multiple languages. Our pre-training corpus, 10 trillion tokens. We prepared a 10T token corpus. It contains diverse text, Japanese, English, code, mathematics, and we carefully designed the mixture ratios. We designed this ourselves. This is crucial to sovereign AI, understanding and controlling all training data to deliver safe, trustworthy models. Now, our post-training improvement cycle. After creating the base model, we do supervised learning, then alignment, as I mentioned earlier. By repeating this cycle many times, we continuously improve performance. We've run this process several hundred times in total. This is how we achieved tsuzumi 2's high performance. Now let me share some evaluation results. I'm most excited to show you the instruction following capability. We give the LLM instructions as prompts in various languages, then measure how accurately it follows them. That's what this benchmark scores. On the far left, Japanese, tsuzumi 2 outperforms GPT-4o and the latest open models, everything except GPT-5. It demonstrates superior instruction following. Not just Japanese, English, French, Spanish too. High capability across the board. Modern AI agents issue complex instructions, so reliable instruction following is critical. Our strong performance here is a real advantage. Safety. tsuzumi 2 also excels here. We match commercial models like GPT-4o and outperform the latest open models, such as Gemma and Qwen. High safety means the LLM avoids inappropriate responses and properly refuses harmful requests. These capabilities have grown significantly. This gives you confidence in deploying tsuzumi 2. Let me show you another example. Imagine a Japanese language beginner writes an email in hiragana. Can we convert it to fluent Japanese? And can we explain the changes in English? Let's see. We start with hiragana text containing various errors. Then we give instructions in English. Convert this email to fluent Japanese. Provide an explanation, formatted as a table. That's the request. Here's a comparison. Tsuzumi 2 versus GPT OSS 120B. Tsuzumi 2 has fewer parameters and doesn't use reasoning in this case, so output appears immediately. GPT OSS on the right is now ready to respond. We finally have output. I can't go into detail today, but both follow instructions precisely. As you can see, tsuzumi 2 is truly fluent, writing emails at a natural, everyday level. The hiragana elevation I mentioned earlier, you can see that clearly in this example. And it works equally well in English and Japanese, making it accessible to a wide range of customers. Finally, I'd like to share the direction we're heading. We're creating a general-purpose AI thinking engine that coexists naturally with people and nature, in any environment, to realize people's well-being. For example, collaborating with people from inside a computer and eventually robots that grow alongside people as life partners. We see two main directions for the future: being naturally accepted by society and growing with people every day. These are the two goals we're pursuing as a research institute. First, natural acceptance. Right now, our society is doing a lot of prep work for AI. AI requires that setup to function. Recently, the concept of agent AI has emerged, and as human-AI interfaces continue to develop, this interaction loop will start running smoothly. We believe AI will play a more natural role in society. To achieve this, we need various multimodal technologies, and among these, voice is particularly critical. To talk about this new voice-enabled AI in the LLM era, I'll now hand things over to my colleague Asami.
I'm Asami from NTT Human Informatics Laboratories. I'd like to take a moment to discuss AI that converses with people using voice, our new voice dialogue AI for the LLM era. Voice as an interface between humans and AI has become increasingly widespread recently. Voice is something we use naturally every day. So it requires no training, no complex operations. It's something that anyone can use. Plus, when your hands are busy, or you can't look at a screen, voice is still accessible. With this voice dialogue AI, we can expand both AI users and use cases. So, what does this voice dialogue AI do? What will it do? Let me explain in a bit more detail. Voice dialogue addresses not just what the AI says, but also when it should speak. These are the two key challenges. On the left side of this slide, you see text dialogue. In text dialogue, the AI only considers what to answer. The user presses Enter or clicks Send, and that signals when to respond. The timing is user-controlled. Voice dialogue on the right has no Enter key, so beyond what to answer, the AI must also determine when. The AI decides whether to speak, what to say, and when. Voice dialogue AI must consider both of these aspects. This question of when to speak, like passing turns, is called turn-taking. It's a fundamental challenge in voice dialogue and an active area of research. This slide shows a conversation between two people. Below, under turn, each person's speaking segments are color-coded, 2 colors representing each speaker. You can see complex overlaps and gaps, a complicated exchange pattern. These overlaps and gaps, they all have meaning. For example, when one person is speaking, inserting brief back-channel responses can encourage them to continue. Or around the middle here, one person is speaking, and you sense they're wrapping up, so you start talking slightly early, overlapping. This keeps the conversation tempo lively. Or, after someone speaks and there's a pause, you judge that their turn is over and begin speaking yourself. This complicated process, humans barely notice it. We all do this unconsciously in conversation. AI capable of complex conversations, human-like, natural turn-taking. That's the new voice dialogue AI we've developed. We have a working demo at booth A08 in the basement, so please stop by and check it out. Now I'd like you to hear a comparison with traditional voice dialogue. Here's what traditional voice dialogue sounded like.
どのようなご用件でしょうか。
はい、今月ちょっと買い物でカード使いすぎちゃって、リボ
なるほど
払いにしたいん。
カードを使いすぎてしまったとのことですね。リボ払いなどの変更をお考えですか。
はい、リボ払いにお願いします。
リボ払いに変更したいということですね。
はい、これがちょっと耳に残っている間に新しい方の音声対話 AI の会話を聞いていただこうと思います。
お電話ありがとうございます。NTT 116センター担当の佐藤でございます。
すみません。
はい。
昨日引っ越しをしたので、ちょっ
はい
と住所変更の手続きをお願いしたいんですが、
はい、かしこまりました。それではご契約内容の確認をさせていただきますので、
はい
まずお客様のお名前をフルネームでお聞かせいただけますでしょうか。
はい、佐藤一郎です。
佐藤一郎様ですね。
はい
はい、お電話番号もお伺いしてよろしいですか。
090-1234-5234、
090はい、1234はい、
5678です。
5678でございますね。はい、
はい
ありがとうございます。お客様ご利用者ご本人ということでございますので、
はい
契約内容の確認いたしますので、少々お時間頂戴していただけますでしょうか。
はい、わかりました。
はい、恐れ入ります。
こちらですね、
The female operator's voice you just heard, that was AI. I think it felt remarkably human. The traditional voice dialogue on the left uses voice recognition for the user's voice, an LLM to generate the response, then voice synthesis for the AI's voice, going through all these steps before responding. This can lead to gaps in the conversation, and when both start talking simultaneously, it interrupts awkwardly. I think you could sense that unnaturalness. By contrast, the new voice dialogue AI on the right provides back-channel responses while listening, responds with almost no pause, keeping great tempo, and I think some of you felt it was truly indistinguishable from a human. Let me show you a bit of how it works. This diagram resembles Nishida's LLM slide from earlier, and in fact, the structure is quite similar. The LLM we discussed earlier divides text into token sequences and processes those. This system divides audio into tokens for processing. The user's voice is broken down into very short segments, under 0.1 seconds. Each 0.1 second input produces one 0.1 second AI audio output. This streams continuously from left to right, processing in real time. So there are no processing delays or awkward gaps. The AI has been designed to respond at optimal timing at every moment. The model is trained by listening to natural human conversations. So it learns not just what people say, but also when they say it. The model learns entire conversations holistically. This new voice dialogue AI, full duplex voice dialogue AI, can now handle natural conversational exchanges. But when it comes to intelligent conversation, it still falls well short of text-based LLMs. Going forward, we'll integrate with Tsuzumi for more intelligent conversations and control for inappropriate responses. And since it's voice, we also want to control things like tone and speaking style appropriate to different contexts. We'll advance this R&D toward commercialization. This will make AI more relatable and better accepted by society. We believe we can help realize that vision. That concludes my presentation. I'll hand it back to Nishida.
Let me return to the LLM direction we discussed earlier. Asami explained the concept of human-AI collaboration, and we're exhibiting that as orchestra search. It connects internal systems, LLMs, and people through intelligent search. The LLM acts like a conductor, orchestrating various agents to solve problems. We're demonstrating this at the booth. This is an English example, but it works in Japanese too at our booth. When the LLM first receives a user query, it plans which agents to query with what questions. Then it dispatches queries to those agents. Each agent queries its own databases and other resources, then returns responses to the orchestrator conductor. A key feature is that the system also queries people, knowing each person's expertise and strengths. The LLM knows who has what knowledge, so it routes questions to the right people at the right time. Here it's querying a manager, getting results back, and finally the orchestrator compiles a report to answer the user's original question. This shows LLMs and humans working together naturally. We're conducting research and developing toward that future. NTT DOCOMO is also developing a voice-based meeting support agent for internal deployment by fiscal 2025. This is also on display, so please check it out. The agent can act as a proxy, particularly for managers responding to brainstorming. I find that particularly interesting. The second direction is people and AI collaborating. To achieve this, we need to go beyond RAG and tuning. Currently, we use these to customize AI for customer needs, and that's the mainstream approach. But to grow AI effectively, it requires time and cost. Problems still exist. Our ultimate goal is AI that grows with people every day. We want to develop technology that enables this. As AI collaborates daily, why did something succeed? Why did it fail? What should it learn? The AI judges for itself, grows, and adapts. That's the kind of LLM we want to create going forward. That concludes the technical section from Asami and me. Thank you for your attention.
Thank you, Mr. Nishida and Mr. Asami. You showed us Tsuzumi 2's evolution, how Tsuzumi became more responsive, and the challenges and evolution of voice dialogue AI. Thank you for the insight. Now let's move to the business side. We'll hear from Mr. Arakawa of NTT DOCOMO's Generative AI Task Force on pioneering the future with AI agents. What you're seeing now is the exhibit we mentioned earlier. It's on display in the B1 patio, so please visit and experience it for yourself. Mr. Arakawa, the floor is yours.
Thank you. I'm Arakawa from NTT DOCOMO Business. Nice to meet you all. I'll be covering the business side. I know you've heard about it already, but I'd like to talk about AI agents. First, let me introduce myself. I work for NTT DOCOMO Business on a brand called Kotoha. We launched it nearly 10 years ago. So I've been working in AI for about 10 years, spanning both development and business. I'm sure you've all heard that 2025 is being called the Year of AI Agents. In terms of ROI, next year is when it really starts. But until last year, LLMs plus RAGs were the mainstream, question and answer systems. Here, I'm asking about a business trip route, that people don't really want the route. It understands the primary purpose, I need to book a business trip, and then plans and acts autonomously toward that goal. That's the concept of an AI agent. So what does the future look like beyond that? It's a whole new world. In short, we're entering an era where AI is no longer just a tool, a world where AI works alongside us like a colleague. I think this vision is starting to feel real. And for people, time and skills will be enhanced by working with AI agents. That era is coming. So what characteristics do AI agents have? Let me give you a quick overview. First is planning. This is very significant. This became possible thanks to the development of LLMs. Until now, workflows were partially rule-based. Humans could define the rules, then operate AI based on those. It was about using AI as a tool. But that required defining countless rules to match real-world complexity. And there were cases where processes just didn't match. But with planning capability, AI can act autonomously when given a goal. This vision becoming reality is a key characteristic. The second are tools. I think of these as hands and feet for AI. We're seeing a world where AI can move easily in digital space. For example, function calling, or a new standardized protocol called MCP. These technologies are emerging, and when using AI, you want to work with all kinds of data. You get results by handling diverse data sets. The second point is that these tools are now in place. Third, going back about 10 years to when deep learning took off, another major aspect is memory. Short-term and long-term memory. How to handle these has been a challenge. But with LLM development, we're now capable of this. Short-term, what did I say yesterday? Long-term, this past month, this past year. What patterns emerge from all of that? LLMs are learning to measure and leverage this data. With planning, tools, and memory bringing AI closer to humans, we're seeing a world where AI agents can act like people. These characteristics make that clear. Moving forward, the question of roles, how to divide work between humans and AI, will define this era, a key point of what some call Year One. And even further ahead, personality. Right now, most AI you use is like a straight-A student. They have massive knowledge, and you're drawing from that knowledge base. But when AI works alongside people, each will have specialized expertise. In some cases, we might even give them a personality. That's the kind of world AI agents will bring. Looking at these characteristics, where are we currently in the relationship between people and AI? Let me share my perspective on this. First, substitution. This means simple, repetitive work. There are still many simple tasks handled by humans. Now, with planning capabilities instead of just rules, AI can handle a much wider range of tasks. That's step one. Number two, augmentation. This means supporting the work people are already doing. maximizing performance and handling what people can't. That's where we are now. For example, with sales data, analyzing past patterns to suggest next approaches. AI can go one step ahead like that. Finally, collaboration, where humans and AI each have defined roles, with individual personalities and expertise cooperating in their strengths. That's the vision. Currently, we're in that second phase, augmentation, which is really taking off. That's what I'm seeing. Today, I'd like to show you working demos, so I brought two examples. One is a sales support agent. The other is more specialized, a patent work support agent. Let me walk you through these. First, sales. How does the sales process work? Looking back, first, you prepare before visiting the customer. Then you meet, have a conversation, listen to them, and draw out their needs. After the meeting, you review and wrap up. Then consider and prepare for the next meeting. That's the flow. At each phase, agents can be there supporting you. That's becoming possible. This is something we're developing now. Let me show you. There are many tools that record and summarize meetings. But this goes beyond recording, in real time. It structures customer info, and depending on the situation, can suggest what to say. That kind of assistance is becoming a reality. I think we're nearly there. After the meeting, the transcript flows by, and it summarizes. What were the key points? And how did this meeting progress? What angles were covered in the conversation? That analytical wrap-up is handled by the agent. During wrap-up, you want different perspectives, so you can ask, what about ROI? And get additional analysis, all provided by the agent. After wrap-up, how do you move toward the next proposal? You want to plan while the info is still fresh in your memory, and the agent suggests next actions. By keeping the process speedy, the information is fresh in your mind, and you can craft a story for the next proposal draft. Once the draft is ready, you start preparing for the next meeting. First, can you tell your proposal story effectively? Will it work? After clarifying the next agenda and goals, you simulate with AI. AI plays the customer. Does your story resonate? Can you deliver it? It's all simulated. AI scores the results from multiple angles and gives feedback. By repeating this, the story becomes internalized, so your proposal is persuasive and resonates in the meeting. With this cycle, your sales effectiveness improves, both individually and as a team. Analysis isn't just individual, it's cross-team, comparing against past meetings and patterns. That's the world where agents work alongside you. Next, a more specialized use case, patents. With patents, as outlined here, first comes the idea. What invention, what development? You generate ideas. Once you have an idea, what are the key patent points? Researchers and developers are naturally focused on their own work, so their perspective can be narrow. By conversing with AI, that perspective broadens. Next, what's the core value? AI drafts first. You review the draft, layer in your thinking, and ultimately shape it into patent-ready language. This is easier to see in action. So let's look at the demo. Here, you enter your invention idea and start dialoguing with the agent. The agent suggests 3 potential directions and drafts each one. You review them and decide which direction to take. You provide feedback, and the process continues. In this case, we're going in the first direction. Then there's human in the loop. I'll touch on this shortly, where human and AI go back and forth, refining together. Once direction is set, the agent follows patent format to create the main claim, the core patent point. It generates that for you. Once drafted, you review it. How does this look? It asks for your feedback. In this demo, we say it's fine, but you might say not quite, or talk about a critical point. Layer in that feedback, and it reconsiders the main claim. By repeating this, you get higher quality, broader invention points. That's how it shapes out. Once complete, since patents are specialized legal documents, automation helps with the specialized formatting. AI outputs the required specifications into a Word document. After drafting, you'll likely want to make adjustments, and you can edit those sections directly. This changes the game. Traditionally, patents come after development and after research. There's a filing process. But now, when conceiving an idea, patenting can happen in parallel, side by side. You can generate IP continuously. By securing these patents, our capabilities expand. That's what this use case aims to enable. Let me shift gears. Many agents like these will emerge, but we see three keys to successful adoption. First, industry and task specialization. I just showed you patents and sales, but deeply understanding the business process is key. Second, human in the loop, or human on the loop. Human in the loop means humans and AI interact directly. Human on the loop is newer. AI operates autonomously, with humans managing and monitoring. Humans step in only when needed. But we can't leave everything to AI. Human intervention to improve accuracy is especially critical this year and next. That's why we prioritize human in the loop in our development. Third, security. With AI agents, as I mentioned with tools earlier, they access diverse data. That's where they show real value. But AI accessing all that data brings security risks. Some companies can only handle data on premises or only on private cloud. You need to align with those security policies for successful deployment. Our approach: rather than custom building for each company, which takes too long to deploy, we pre-build AI agents with specific roles. Then, customize for industries, finance, manufacturing, public infrastructure, speeding deployment while keeping process expertise. We're building agents that understand workflows. On infrastructure, security has many factors. Where can you handle data? On-premises? Private cloud? At individual factories? At the edge? We provide environments where AI runs while connecting all that data. Now, about tsuzumi. How do domestic LLMs fit in? Let me briefly cover two main points. First, passing on tacit knowledge. You have to teach agents. Business processes, all sorts of things, they need to learn. But then there's tacit knowledge. Is every task manualized, fully documented? Never. Even places that claim to be well documented aren't. Manuals can only capture so much. It happens all the time. People understand what's between the lines, beyond the manual. Understanding beyond the manual is critical. So RAG has its limits, because veteran expertise lives in that space. That situational judgment can learn from massive, tacit knowledge to make situational judgments. That's one major point. Second, private LLMs. In some cases, data can't leave the country for security. That happens often. But if you can't handle data in cases like that, you can't fully solve the problem. Entire workflows might fall apart. By controlling that learning data while maintaining sovereignty, this is where we see Tsuzumi's value. Specifically, we see this as the last mile for AI agent deployment. Tacit knowledge learning for industries. Private LLMs for security. With these, each company can use AI to transform their business processes. That's the last mile. And the top right corner. This refers to AI that continues to grow through human collaboration. 2 points here. As Nishida and Asami covered earlier, first, self-growth. This is where small LLMs become effective. Knowledge becomes skill. We all go through this cycle. This is also an era where AI can grow on its own. I think this will happen in the near future. We're looking forward to this in our research. The other is moving from back and forth to joining conversations. When you're with colleagues and you talk to each other, do people wait? They don't. People could be saying, "It's A, right? I think it's B," and then another jumps in with, "No, it's C." They interrupt. A world where it's not just back and forth, but truly blended. If we realize that, AI can finally act like a colleague. Toward that future, toward an era where AI and people work together, both in research and in business, we're looking to expand in these areas. That concludes my presentation. Thank you very much.
Thank you, Mr. Arakawa. The current state of AI agents, concrete examples, and what we need to consider for implementation. I hope you all have a clear picture of that now. Now I'd like to move on to the panel discussion. But first, let me ask you a few questions. How many of you use generative AI in your work or daily life? Anything? Could you please raise your hand if you use it? Almost everyone. Looks like nearly everyone here. What about AI agents at your company or at home? Is anyone using AI agents? Oh, a few hands? Thank you. Now we have a sense of where things stand. Thank you. So, from generative AI to AI agents, let's talk about what's happening and discuss more. Let's start simple. Current generative AI technology. Mr. Arakawa mentioned patents and agents. Now, let me ask Mr. Nishida and Mr. Asami. Something like that patent tool that does the work for you. Would you want to use it? Or what would you like it to do? Please share your thoughts or any requests you have. Mr. Nishida?
I definitely want to use it. As a researcher, I write patents. I've done it many times, and it's quite specialized. It's hard to achieve high-quality work alone. Having an LLM answer my questions again and again, and having an AI agent investigate by searching web information and past patents, I think we can create very high-quality work going forward. I have high hopes for patent AI agents.
Thank you. Mr. Asami? I'm already using it, actually. That's where we are. The latest research and papers, they're coming out every day in this field. Just keeping up with it is overwhelming. So I asked the AI to summarize things for me. I'm already using it for that. And an AI digging deeper into patent content and drafting specifications, having support for that, I'd use it without any hesitation. As a researcher, solving problems no one else has solved, that's the most essential part. More time for that? I really welcome it. Thank you. Mr. Arakawa, any thoughts?
The moderator is asking questions we can only say yes to. From a business perspective, that's very appreciated. Every day, discussing with researchers and developers, we're building more concrete, practical solutions. If anyone's interested, we have an exhibit. Please come and see it.
A little promotion at the end there. Thank you. Let's go to the next question. AI agent business. As we just heard, some people here have started using agents, but many still have a ways to go. AI agents are trending right now. From now on, it's less about generative AI and more about adopting agents. That's the conversation we're having. But with AI agents, people have different images. My AI agent, your AI agent, lots of different conceptions. Let's ask Mr. Arakawa, who's actually in the AI agent business. What specific requests do you get from customers? Or how do they intend to use it? Could you share some specifics? And after that, I'd like to hear about R&D efforts toward those goals. First, Mr. Arakawa.
Earlier, I talked about substitution, augmentation, and collaboration. By far, substitution use cases dominate. Checking, generating, and supporting the creation of large volumes of text. While creating, it pulls information from RAG, internal databases, and leverages past knowledge. As the scope expands, it accesses various information sources. That's a big driver. Companies will be investing ahead of the curve. For example, generative AI, which everyone is using, it's excellent for ideation as a sounding board. So, ideation plus automation. I think we'll see use cases like that emerge everywhere. We're already getting that feedback. Recently, we've been looking into ways to utilize tacit knowledge to pass on technology, like how to gain tacit knowledge through interviews. How can we ultimately extract insights? And with those insights, how do we integrate them into automated processes? I think those use cases will increase.
Thank you. Moving forward, it feels like we'll be stepping into more difficult territory. Given these requests, these intentions from all of you, for example, Tsuzumi 2 and things like voice dialogue, what contributions can NTT R&D make? What strengths can be leveraged? I'd like to hear from our panelists. Let's start with Mr. Nishida.
Going forward, interactions between LLMs and humans will truly increase. Understanding the intricacies of Japanese is what we want to strengthen with Tsuzumi. And as mentioned in the presentation, LLMs continue to grow and adapt to us. We're steadily developing the necessary technology for that future. A future where LLMs get smarter every day. That's what we're working toward.
Mr. Asami, thoughts about audio? From an audio perspective, we talked about collaboration. That's a key part of speaking. We start speaking the moment something occurs to us. Like, hey, what's going on with this? It's a very immediate medium. As AI continues to develop, from a vague initial thought in a conversation to let's research this specifically, it helps us make things concrete and plan out actions. This is AI and humans truly collaborating to solve problems together. That's where we're heading, and I think we can get there. I'd like to keep advancing our research in that direction. Thank you. Now I'd like to ask, what isn't possible yet? For tsuzumi 2, language processing, speech processing, what can't you do yet? What new skills for AI are you working on next? Could you share your thoughts?
Right now, AI still lives inside computers. In the future, AI will have a physical form in our daily lives. AI and LLMs providing that support, that's where we're headed. This expansion centered on LLMs is what NTT Laboratories as a whole is aiming for.
Mr. Asami? What we can't do yet, but I'd like us to be able to do. Something important people often say is, could you take care of that? What exactly does that refer to? A really good secretary or agent can sense that and do what needs to be done. But you need a really deep understanding of that person, or you won't know what that is. Understanding users, understanding each individual. If we could really do that, it would be an amazing world. Thank you. I hope we can get there. We're running out of time. Last question. The topic was the future of AI, and in the presentations, we talked about things like coexistence and AI working with humans. I think that was clear. What will happen to society and our lives with AI in the future? From a researcher's perspective and from a business perspective, what do you think the real future looks like? Please be specific if possible. Mr. Nishida, let's start with you.
True symbiosis, coevolution, collaboration, humans and AI together, working so naturally you don't even notice it's AI. That kind of world will definitely come. Both humans and AI meeting in the middle, shaping society together. That's where I want to contribute as an engineer.
Mr. Asami? As AI advances, especially as AI agent technology develops, each person will have their own team. I think that's definitely where we're headed. The amount of work one person can do will expand far beyond what it is today. When each person has a team, what can those teams do together? I haven't really thought about it until now, but it's something I want to keep exploring. Thank you. Finally, Mr. Arakawa, from your position, what does the future look like in the AI agent business?
Right now, we talk about introducing AI agents. But many forms of introduction will emerge, so agents will multiply. In the future, it will be normal to use active AI agents. The question becomes, how do we design them into our business, our lives? I think that will become mainstream. For our business, earlier I used the term human on the loop. As I mentioned, assuming AI is part of the equation, the key is, how will the process itself change? That will greatly increase company value and change our lifestyles. I believe that day is coming soon. As we step into that space, we want to be as useful as possible.
Thank you. It looks like we've run out of time. Sorry for the sudden ending, but that's it for our panel. I'd like to thank our panelists and all of you in the audience. And thank you so much to everyone who attended.